We are going to practice graphing quadratic functions by hand, but also in our calculator. So something I need you to write down on the top is the standard form of quadratics. Y equals ax squared plus bx plus c. This is called standard form. So a lot of these things are on your formula chart, which you will have access to whenever you take your test. So let me show you where that's at real quick. If you go here, see how it says quadratic equations? We have all of these for quadratics. Standard form is this, ax squared plus bx plus c. So a, b, and c are numbers that will be used for the quadratic formula, which we will learn more about that too. And then the axis is symmetry. That's the line that cuts the parabola in half. And then vertex form is something we'll do later. Something I do want to point out real quick on quadratic formula is it has this plus minus, and that's not a new symbol. That just means you have two answers. You rewrite it two different ways. One way will have a plus, and then the other way will have a minus. It's two different answers. But the way that mathematicians do it is to save some room and put plus or minus on there so it looks like that. You might see that on your test. So whenever we graph these, we're going to use the standard form. We're going to identify A, B, and C. We're going to write A equals, B equals, and C equals. Once you identify A, B, and C, then you start with step one. You find your axis of symmetry. You use the values for A, B, and C and put them in here. So it says negative B over 2A. So this is on your formula chart. Then step two is to find your vertex. So you find it by hand by plugging in the x value into the quadratic equation. Or what we're going to do today is use our calculator and the table to find it. So go ahead and write the steps for the calculator. I'm putting calc right here. And you're going to put y equals. You're going to plug in the quadratic function into y equals. And then hit second graph to go to the table. You can also click graph just to look at what the graph looks like. Is it upside down or is it right side up? Is it high on the grid? Is it low on the grid? You can use that. Then you're going to find your y-intercept. Yesterday we learned that the y-intercept is the c value. So it's the value on your standard form that doesn't have an x value. And you write it as 0, c. So you have your axis of symmetry, draw your dotted line down the middle. Your vertex is the point where it changes direction. Your y-intercept is where it crosses the y-axis. So just as a reminder, draw your x and y-axis. Label your x and label your y, just so that you can remember that. Okay, then step 4 is plot the vertex, draw the axis of symmetry, plot the y-intercept, and use symmetry to get the third point. So we're actually going to end up graphing 5 points. So put on here, make a table using calc, period, uh, and graph 5 points. Okay, step 5 is optional. We're not actually going to do that today. It just tells you some things in the calculator that you can use. We're not going to do that today. So go ahead and open up the foldable. Okay, so we have a function. And we need to first find the axis of symmetry. So I'm going to write the formula here. AOS for axis of symmetry. And that was the formula on the front. X equals negative B over 2A. Remember, you don't have to memorize that. It's on your formula chart. So in order to find your axis of symmetry, step one, or I guess before step one, we identify A, B, and C. So I'm going to write that out to the side. A is the number in front of x squared. So if I do ax squared plus bx plus c, the a would be 1 because there's an understood 1 there. And then b is 2 and c is 3. So they come directly from the function. So we'll find the axis symmetry by plugging into the formula. So x equals negative b over 2a. So that's just a formula, not something you have to remember on your formula chart. So we'll plug in our numbers. Negative b, so negative 2 over 2 times a, 2 times 1. You can do it by hand, or you can use your calculator. So remember in the calculator, you can go to alpha y equals to get your fraction template. So go ahead and do that. I want everybody to practice putting them in their calculator. Negative 2 over 2 times 1. Negative 1. So our axis of symmetry is x equals negative 1. Remember, the axis of symmetry is the number that divides the parabola in half. It's a dotted line that we draw. So go ahead and draw the dotted line on negative 1. So that's your axis of symmetry. So now we're going to start using the calculator. We're going to make a table. And you're going to start with the axis of symmetry where x is negative 1. And that's how you're going to find your vertex. So we're going to plot it in y equals. So everybody go to y equals. Plug this in. X squared plus 2x plus 3. So what I say do first is just look at the graph just to kind of get an idea of what it looks like, and then go to the table to get a few points. So make sure this is in. Then hit graph, which is just that one, that last gray button. So it looks like it's up and over. It's in that second quadrant. The vertex is above the x-axis. So we kind of get an idea of where it's at because we're going to be able to draw it. So now go to the table, so second graph. And I want you to start at the axis of symmetry. X, see the x, and negative 1. So go to negative 1. Where x is negative 1. And that's at 2. So that is our first point, which is also called the vertex. Negative 1, 2. So plot that point. Negative 1, 2. And it is supposed to be on the axis of symmetry. So go over negative 1 and up to 2. And then the y-intercept is the c value. See our c right here? It crosses the y-axis at that 3. And we write it as 0, comma c. 0, comma 3. C is right here. All right, so that was another point. And I'm going to put it on the table because I need one more. So I'm going, see how it's in order right now? Sometimes it does that, sometimes it's not. But in this case, it is. So I want to go to the next one. -1, 2, 0, 3. So the next one is 1, 6. So go over 1, up to 6. And that gets me a third point. So then what we do is, remember this is the axis of symmetry? That means that it's symmetrical across that line. So symmetrical means you can reflect this point to the other side because they look the same on both sides. It's kind of like a mirror image. So see how this one is 1 away from the axis of symmetry? So we go 1 on the other side because they're supposed to be symmetrical. And you do the same thing with this point. It's 2 away from the dotted line, so we go 2 to the other side. And now I have 5 points. You can also look at your table. -2, 3, and 3, 6. Look at how your y values are symmetrical too. There's the vertex, and they have the same y values on both sides of the vertex, going to the negative side and going to the positive side. See how it's symmetrical? Pretty cool. Okay. So now we're going to graph it. So the bottom 3 points makes like a bowl. So make your bowl or your U. And then follow it to the next point and then put arrows on it. And then you do the same thing on the other side. So it looks like a U. Does not look like a V. All right, yesterday we talked about domain. If there's arrows on left and right, because domain is x values, which the x-axis goes left and right, it's all real numbers. And it goes to infinity, so you could say -30 to positive. Okay, and then I'm going to skip range and come back to it. Maximum or minimum? Does this quadratic function have a maximum or a minimum? Yeah, because it's your lowest. So max would be if you have a highest point, and then minimum would be if you have a lowest point. So that's a min. And yeah, it's 2. You look at how low does it go. Your max or min is on the y-axis. How low does it go? So we would put 2 there. Okay, we'll go to the next one. It says, how many root solutions x-intercepts are there? Does it cross the x-axis at all? No. So it's none. There's none of them. So we can put a 0 with a slash through it. There's not one. No real solution. All right, the last thing is range. The range is our y values. And where we get our range is from our maximum or minimum. So we have I forgot to circle minimum. Where we have a minimum, we put that number. It's going to be greater than or equal to because it's at that number or higher. So greater than or equal to. All right, so let's go to number 2. First thing we need to do is identify A, B, and C. A, the number in front of x squared, so that's a -1. B is a -4. And C is a -4. So we have A, B, and C. Now we can do our axis of symmetry. So -b over 2a. So -b. Well, if b is already negative, if I say negative, negative, That cancels out. Negative 4 is not going to work. It's going to be a positive 4 over 2 times negative 1. So we can put this in the calculator. Alpha y equals, get our fraction, 4 over 2 times the negative 1. Make sure you know how to put this in. If you need help, ask me. Okay, so that's a negative 2, so we're going to write x equals negative 2. So draw your dotted line down the negative 2. You go to the x-axis, go to negative 2. That's our axis of symmetry. Now go to y equals and graph it. I want to get an idea of what it looks like. So I'm going to click graph to see it. So it's upside down. And the reason it's upside down is because the a value. A is negative. If it's positive, it's a u. Negative a means it's upside down. Now go to your table, and we want to start at the axis symmetry, so where x is negative 2. Go ahead and make your table. We're going to start our table here at negative 2, 0, because that's what it tells me right here. That's my vertex. And look at how this is symmetrical. See your table? Symmetrical. It has the same thing on the y's. All right, so negative 2, 0, be right there. Our y-intercept is the c value. So that's your y-intercept, 0, negative 4. So plot that on the y-axis. Go to negative 4 on the y-axis. Okay, so there's one point in between that, though. So go to negative 2 on the table, right here. Let's plot the point that's in between there. Negative 1, negative 1. So negative 1, negative 1. Now we could just reflect the point. So see how, where this one's at? Reflect it. See where the next one's at? Reflect it. 1, 2, 1, 2. Now do your parabola. Start with your top 3 points. If you go back to your table, you can see it's the same thing. Okay, your domain, since we have arrows going left and right, it's all real numbers. Okay, do we have a maximum or a minimum? Yep, go ahead and label it. Circle maximum. What is it? What is the highest point? Yep. It would be this, which is 0. Negative 2 is the x, but when we're talking about max and min, we only look at how we measure height, which would be the y-axis. Okay, how many root solutions, x-intercepts are there? 1. There's just one. I'm going to write the word 1 so that it's not confusing. Where is it at? 4. Nope. Right here. -2. Yeah, because we're talking about the x-axis. Then our range comes from the maximum. Since it's at this number or lower, then we're going to write the inequality for less than or equal to. All right, let's look at number 3. This one looks different. It has an x squared there, but it doesn't start with it because it's not in standard form. Ax squared plus bx plus c. But what we can do is just rewrite it in the right form. So y equals, I'm going to bring the x squared front because that says a positive x squared. I'm just going to put x squared. Because this is a -4, I'm going to put -4. There is no bx. So what does that mean about b? Is there one? It'd be like 0x. So a is 1, b is 0 because there's not one. We could have written this as x squared plus 0x minus 4. And then c is -4. Okay, x symmetry, x equals -b over 2a. -0 over 2 times 1. If I have 0 and I divide by any number, I get 0. So anytime b is 0, your x symmetry is going to be 0 because that b is a 0. So this would be x equals 0. We'll make a table of values starting with the vertex where x is 0. Go to y equals and put the new function in. So that's at x squared minus 4. Or you can put in the original, -4 plus x squared. The order doesn't matter as long as they are the same. So I like to usually just put in what they've given us, -4 plus x squared. Just in case I rearranged it wrong, I would still get the same answer here. Look at the graph, see what it looks like. So that way you'll kind of have an idea of how you're going to graph it. If you can't see it, you're going to have to zoom out. I don't think we have any on this where you have to do it though. Hit the graph. So we know it's right side up. It's a regular U, but it's kind of shifted down on the y-axis. So let's go to the table. We'll start at 0. So 0 is at -4. So that's our vertex. You always use the axis symmetry to find your vertex. So the axis symmetry is the y-axis because it's at 0. Draw your dotted axis of symmetry or dashed axis of symmetry. So 0, -4. And then let's find some points. Oh, what's our y-intercept? What's our c value? What's our c value? So it's actually the same thing as the vertex. Okay, so now we just need points to the left and right. So let's go to the next point. 1, -3. Over 1, down -3. 2, 0. Over 2, 0. And this one actually gives us enough room to plot another one. Let's do 3, 5. Over 3, up to 1, 2, 3, 4, 5. Okay, so now we reflect them. So if it's over here, we flip them across the axis of symmetry. So as many points as you have on the right, you should have on the left. And go ahead and connect your points to make a parabola. Okay, domain is all real numbers. It's always going to be that unless you have endpoints on it and it says, like, if it had points like that and there were no arrows, yeah. But whenever you graph it and it doesn't tell you it stops at this number or anything like that, it's going to be all real numbers. All right, this is a lowest point, so we have a minimum. And the minimum's the lowest, so how low does it go? It goes down to -4. And then our range is y at -4. So it's at -4 or higher. So the symbol is going to have to be greater than or equal to. Yep, there's two places that it crosses the x-axis, which is called a zero, root, and solution. So there's two of them. I'm going to write out the word 2, just so I don't think 2 is where it goes through. But in this case, it does, right? Where does it go through? 2 and -2, like that. We could have also wrote this as x equals plus minus 2. That's a way to write an answer, like the shortened term. That means, this means you have both answers. Just a shortened way of writing it. Okay. All right, you're going to do number 4 on your own right now. All right, so I have already written down A, B, and C and found the axis of symmetry. This is similar to number 3 because you have a B that's a 0. Anytime you do 0 divided by a number, you're going to get a 0. So then our vertex comes from putting into y equals and looking at the table where x is 0. So let's put that in. So it's negative x squared plus 3. Go ahead and look at it, see what it looks like. Because the a is a negative, it's an upside down u. It's flipped over. So then we'll go to the table, find out what 0 is. 0, or x is 0, y is 3. So that's our vertex. So you can always find your vertex after you find your axis of symmetry. So I'm going to go ahead and do my dotted line down 0. And plot a point at 0, 3. And that's actually my y-intercept too, because it's where it crosses the y-axis. And it's my c value, 0, 3. So they're the same whenever your dotted line is down the y-axis. Your domain, well, let's go ahead and find some more points. All right, I need to go down from the vertex. So 1, 2, And then my next one on my table is 2, -1. And I can actually graph my next one, which is 3, -6. I can't graph the next one because see how that's -13 and my graph doesn't go down there? But you can look and see how this is symmetrical. And 0, 3 is right there in the middle. That's our maximum. See how 3 is the maximum y value? It goes up to 3 and then it starts going back down, changes direction. So I'm going to plot these points. So 1, 2, 2, -1, and 3, -1, 2, 3, 4, 5, 6. And now reflect across the axis of symmetry. So we have this one, we're going to flip over here, this one, flip over here, and this one over here. Make your parabola. Okay. Our domain is going to be all real numbers. Okay, do we have a maximum or a minimum? It's the highest point, so it's a max. And we got to know how high does it go? 1, 2, 3. How many solutions, roots, x-intercepts? It's where it crosses the x-axis. And it's not on an exact point. Like that's not at 2. It's a little bit below 2. This looks like it's at 2, but it's not because this is here. So whenever I graphed it, I kind of went off a little bit. But there are 2 of them. We're not going to find what they are right now, but our calculator will find that. Then our range is going to be at 3 or lower because this is our maximum. So maximum 3, so it has to be less than or equal to 3. I'm going to go ahead and glue this in.